with known cross sections. So they tell you the shape of the cross section. Shape of the cross section of circular discs with the diameters running in the XY plane. So this has the y-axis and the x-axis, right? And the z-axis comes out here. But anyway, if we were to graph this, here's negative square root of x and there's positive square root of x. So this is the distance between square root of x and negative square root of x. Right? So this is not the base of the solid. This is like the center of the solid. And if I took out a circle, if I made a circle with this being the diameter, the circle would come out here and we go in there, right? And it looks like we go from 0 to 4. And then this is the point 4, 2, and this is the point 4, negative 2, since it's negative square root of x. So this distance is a diameter. So we have to find the volume of this shape. And it does kind of look like a football, right? It comes to kind of a point there, and then it gets wider, and then it just stops right there. Half of a football. You know, each cross section of a football is a circle, right? Like if you chop the football, you know, you have a circle. Kind of. So how do we find this volume? Well, we know we're going to integrate from x value of 0 to the x value of 4. We're going to integrate the area of the cross section, which is pi r squared. We're going to integrate dx. However, if the diameter runs from square root of 2 to negative square root of 2, where's the radius?
Square root of x.
Yeah, square root of x. That's the radius. It's like the top function minus the bottom function. But you have to divide it by 2 because the radius is half the diameter. And you get the square root of x. So we have to find, the radius in terms of this distance. That distance is 2 square roots of 2, but the radius is half of that. So we're integrating pi r squared. This is x, so x squared over 2 we have to be integrated times pi evaluated from 0 to 4. So it's 8 pi for a. The cross sections are circular discs with diameters in the xy plane. What is this? Oh, it's so sad. So we're going to look at B now. So we're using the same rectangles perpendicular from 0 to 4. Oops, that's not. And now this is the base, like this is the base of the shape. And it says the cross sections are squares with bases in the xy plane. So like, if I were to draw an arbitrary rectangle, it would be right there. But if you make that into a square, and each, this would come out like that, and then the last part would be like that. So the length of the four sides would be the same length as this one side. So the squares are smaller here, right? Smaller squares. The squares are bigger here, further. Right? So this in the xy plane is the base of the solid. Perpendicular to the x-axis, the cross-section is a square. So how do you find the area of a square? Because we're going to integrate for B. We're going to integrate the area of a square dx from 0 to 4. What's the area of a square? You guys, this is like
Side length squared.
side squared, right? So we're just going to integrate from 0 to 4 side squared. And what's the length of one side? 2 times the square root of x. Okay? So we can take the 4 out. 0 to 4 square x squared, you get square the square root of x, you get x dx. That's 2. There's 4. 8 times 4, 32. Is that right? Okay. C, not as easy. We have the same area. So we have the same sketch. Square root of x, negative square root of x, is an arbitrary rectangle, use 4, is 0. But now the arbitrary rectangle is the diagonal of a square. And the square comes out like this and goes in like that. So it's got a sharp corner here, sharp corner here, and then along these are sharp corners. It's like if a football were made out of triangles on each of the 4 sections of the football. Instead of it being bowed, it would be like straight triangle, straight triangle. The shortest side would be here. That rectangle is coming to a point. This rectangle, that's the diagonal of it, so it goes out as a point there, it goes out as a point there. Right? So like, how do you find the area of a square? I know it's side square, right? What about in terms of its diagonal? It's a rhombus. Do you know how to find the area of a rhombus in terms of its diagonals? So the area of a rhombus is 1/2 diagonal 1 times diagonal 2. integrating it to get the area of this, or the volume of this. For a square, what do you know about the diagonals of a square?
Equal?
They're equal. So 1/2
One.
square.
diagonal squared. And the diagonal, this is the diagonal. This arbitrary rectangle. So for C, we just integrate what's the length of the diagonal?
2x squared.
2
2 squared x.
square root of x squared. And that will get us the volume of that cell. So I guess 2 times the integral from 0 to 4 of x dx. 16, is that what it is? It's x squared over 2 from 0 to 4 times 2. Oh, no, yeah, 16. Good? Now an equilateral triangle. I don't know why this is continuing. But I guess that's what I assigned. Equilateral triangle. Based on one side of equilateral triangle. Cross sections are equilateral triangles with bases in the end. Okay, so this picture would be this one except for not, with all this top. It doesn't look like anything. Anyway, cross section. We need to figure out how to find an area of an equilateral triangle based on, like, area equals, and only use S, the side of the triangle, as its variable. Oops. Area equals. Okay, we get to this. If this is the side, the shortest side is s squared. The longest side, half along the side, right? And the height is the shortest side times the square root of 3. So what's the area of this thing?
One half. Base, I'm sorry.
Yeah, 1/2 base, what's the base of this triangle?
X.
S times the height, what's the height of the triangle?
Square root
S squared root of 3 over 2. So this looks like S squared times the square root of 3 over 4. That's what we integrate. You guys, I've never seen anything like this on AP. I've seen squares, and I've seen rectangles where one side is twice as long as the other side. Right? Easy stuff. I've never seen equilateral triangles of these. But anyway, that's what we integrate. Square root of 3 over 4 is a constant. Side squared dx, and the side is 2 squared x from 0 to 4. Four comes out, canceling the 4. this 4 comes out cancel this 4. X squared. What'd you say? 8 squared root of 3? We'll do some known cross-section actual AP questions. They're gonna be like this. That's a little obnoxious. Okay, so let's look at the other ones. Okay. 7 to 10, just these, right? Revolving about the x-axis, revolving about the y-axis. That's right. Okay, so let's do the first 2. About the x-axis, arbitrary rectangle. The height of that rectangle is y. The position of the rectangle is x. So let's do this about the x-axis.
Have to get in terms of y, right? Or like y equals.
Okay, so subtract x. Good. Now we know what y equals, right? And is this Washington method or disk method?
Is
Disk, how do you know?
it's just
Because
circle,
it's
one circle.
revolving. The
The
it's
shaded
revolving is
area?
touching.
Borders the axis of revolution over the whole interval.
Hold.
Whole interval. So this is disk method. We're just integrating pi r squared. It's dx because the rectangles are perpendicular to the x-axis. What about the interval?
0 to
Yeah, the furthest to the left it goes to 0, furthest to the right it goes to 2. Remember, rectangles just slide like that. Right? They go like this. They don't go like that. It's not helpful. They do this to cover some space. Right? 0 to 2. And what's the radius if we revolve this about the x-axis? Radius. There's the radius. It's y.
Isn't it just that?
What is that?
Just the negative half x plus one.
Negative 1 half x plus 1. That's the answer. Do we have to find it? Find the bottom. Suppose so. So if you FOIL that, it's x squared over 4, right? Negative 1 half x times negative 1 half x minus negative 1 half x plus negative 1 half x. One times 1 is 1. Right, you can FOIL it. 5 or 3?
Yep. 2 pounds.
Oh wait, that's the right one. That was. I think it's everything.
Okay,
Basically,
questions?
Just a matter of.
Let's look at, let's do it 2 ways. Let's go around the x-axis and then go around the y-axis. Okay. So, x-axis. Recorder's doing a job. I start the day in it. The calibration is on. So anyway, if we go about the x-axis, our rectangles are perpendicular to the x-axis. Okay. So, do we use the disk method or the washer method?
Yes.
How do you know it's a disk?
Because it's shaded all the way to the axis of revolution.
Here's the axis of revolution. Because we're going about the x-axis.
Wait, I
So
thought it
it's
was,
washer.
no, that was not.
Oh, what is
It is why we're doing both.
Oh, okay, that was
So
one.
then no. So it's wash.
It's washer, right? Pi big R squared minus little r squared. The x rectangles are perpendicular to the x-axis. What's the big radius? It's the, like if we revolve this about the x-axis, right?
Yeah.
What's the big radius
Equals to,
outside of the circle?
equals to.
Yeah, that's the distance from the axis of revolution to the, like the top of the rectangle, or the furthest part of the rectangle. And that's 2 minus 0, which is just 2. And then the small radius, that's the distance from the axis of revolution to the closest part of the rectangle. That's this distance, which is another y value. This distance. It's this, but it has to be in terms of x. Okay? So if x is 3 halves y, then y is 2 thirds x. 2 thirds x. How about the interval?
0
0 to what?
3.
3, yeah. Remember, if it's dx, we have to look at the x-axis to find the interval. 0 to 3. Let's set up this one. Well, it's easier because it's kind of set up. Is, if we go about the y-axis, is this the washer method or the disk method? Disk. How do you know?
Because you revolve on the line and the whole thing is.
Here's the axis of revolution, and the shaded area borders the axis of revolution. Remember the whole thing. Okay, so we're going to integrate, since rectangles are perpendicular to the y-axis, we're integrating dy. We're integrating pi r squared. And what's the length of the radius? The length of this radius is x,
Just 3 over 2.
3y over 2. And the interval?
0 to
Yeah, rectangles move side to side in the interval. The smallest y value can be 0, biggest y value can be 2. this one is 4 minus 4/9 x squared. This one, 9/4 y squared. Integrate this, you get 4x minus, add 1 to the power 3, divide by 1 to the power 4/27 x to the third. Minus 4, 8 pi. Yeah, not so bad. This one, add 1 to the power, divide by 1 to the power, so what is that? 9/12.
3/4.
Put 2 in, get 8, divided by 4, get 2, 6 pi.
Yeah.
So we did it 2 different ways. We didn't do the same problem 2 different ways. We did 2 different problems using the same picture, right? We revolve it around the y-axis. That'll give us like a conic reservoir, right? Holds water, the volume of it. And then this one, if we revolve it about the x-axis, that gives us something with a circular base, but the size this is makes sense. It's that this triangle revolved about the x-axis. Yeah, I don't want to do this one about the x-axis. That would be a little much. Because if you solve for y, your kids, y, pi over 4y equals arctangent of x, and then integrate arctangent. No, not. Ooh, this one's fun. 10. We don't want to do that one about the y-axis. Washer method or disk method? Disk. Right, we're going like this. Length of the rectangle is x. This is pi, something squared dx dy. So rectangles are perpendicular to the y-axis. What about the interval?
0, 1.
0 to 1. And what are we integrating? Tangent of pi over 4y. Do you know how to integrate tangent squared? Is there a function whose derivative is tangent squared? So I'll grab the calculator. That's not fun. Notice I don't have a pie. Zero to one, right? Did you get that?
Oh, yeah.
Yeah? Right?
Almost. How'd you get what I wanted?
It's alpha traits.
Alpha chocolate.
Yeah?
So, like, even though that's y, you can do a calculator of x.
Yes.
Is that it?
Yeah. That's your only option. Okay? How about this one? You know where this number is? Where does that curve touch the x-axis?
Power of 2.
Right, 2?
So,
That's where sine is 0. Well, where is sine times cosine 0? Yeah, cosine is. Oh no, so sine is 0 at pi. 0 and pi. Cosine is 0 at not 0. And pi over 2 and 3 pi over 2. So we're integrating 0 to pi over 2. This function. You can do it by hand. So, this method again. What do you choose for u?
Sum.
Yeah, because du will be cosine x dx. So we're just integrating u, du. That's pi. We want the interval. What's the sine of 0? 0. What's the sine of pi over 2?
1.
That would be easy, right? U squared over 2. And now evaluated from 0 to 1 times I. Plug 1 in, get 1/2. Plug 0 in, get 0. I over 2 is the answer.
Is it sine cosine squared? So it'd be u squared already.
Wait, what?
Isn't it sine cosine x squared? So it'd be u squared already. So it'd be u 3.
What?
It's a
Because then it's
circle,
pi.
so you have to do
Sine x.
R squared.
So shouldn't it be in parentheses squared? So it'd be u squared already.
Oh, because it's oh. And then we can't integrate it. Oh. Yeah, because it's pi r squared. I was so excited to do this, but we cannot. We can't. I mean, we can. You can. You could. Change cosine in terms of just sine. So I have to save cosine. Save one cosine, turn the other cosine, and you can't do it. I don't know. We don't know how to do this. My bad. I was so excited we could integrate sine and cosine with u substitution that I forgot the head of the square. That's it. Okay, so let's do that. I'll just put sine x cosine x in. Zero to